Yo, what's up, guys? Uh, Welcome back. Let's come back here. Another stream. We're back. Little Friday night grind session. Some more problems. Yeah, let's jump straight into it. Gonna take a look at that problem yesterday when my computer crashed halfway through. We were close to solving it, but had that little computer crash. Frustrating, but let's check out this daily problem. Maximum Manhattan distance. Ooh. Interesting problem. You're given a string S consisting of the characters N, S, E, and W, where SI indicates the movements in an infinite grid. North, move one north by unit by one, move one south unit by one, east, west. Initially, you're at the origin 0, 0. You can change at most K characters to any of the 4 directions. Find the maximum Manhattan distance from the origin that can be achieved at any time while performing the movements in order. So we go north. 0 plus 1 is equal to 1. Maximum is 1. Minus 1, 1. The Manhattan distance is 1 plus 1 is equal to 2. One second, I gotta respond to a friend. One second, guys. I will be back in a second. My buddy is here, so 1 second. Oh, my bad, guys. I'm back. Had to deal with my friend really quick. But okay. Back to this problem. Let's take a look here. Maximum Manhattan distance, right? You're given a string. Okay, so we get the string. We got K is equal to 1. What is our K here? Given a string S, initially you're at the origin 0. You can change at most K characters to any of the 4 directions. At most K characters. That definitely does make it a little tougher. You can change at most K characters to any of the 4 directions. Change from south to north. The string S becomes northwest, northeast. 3, hence the output. Okay. Can brute force all possible directions, northeast, west. Change up the K characters to maximize the distance in the chosen direction. I was thinking more, okay, we can brute force, so... So if we brute force, we can go from north. Well, I think no matter where you go, north, south, east, west, I think the Manhattan distance will probably be the same. So I think probably the way to go here right? If we were to kind of look at this on here, I think the way to go here, so if we're given north, west, south, east, right? Let's make this a little bigger. Can't really see that actually. I've got gibberish here. Hang on. North, west, south, east. This is our current string, right? Northwest, south, east. And we got our k is equal to 1. So the way you want to think about this problem, I think, is we probably want a for here. So probably a for loop. Loop through each of these values. We start off at north, right? I think for starters, we would probably exclude the first value actually. And I think we'd probably start off at here, right? So we currently have north, and our Manhattan distance is always, I think, is always going to be 1 in our first case, right? Because no matter where you go, we're going to have a distance of 1. I think. So I think we'd start from the next value, and we'd brute force every single answer, right? So if we can change here, we would brute force every single answer here. I think that's probably the way to go about it, right? Maximum distance after k changes. Let's look here. Most k characters in. I'm not sure if that's the way to go about it. Distance after k changes. So I think that's probably the way that we're going to look at this problem. Start by brute forcing it. So I think what we're going to need here is we're going to need a dictionary here. We probably want to map north to being north would be 0, 1. We map our south to be 0, right? North would be 0 minus 1, actually. I think that's what our north would be. Or is it? No, wait. 0, 1, because we would go. Geez, how am I messing this up? I should know this. North going up would be, yeah, adding, plus. And going down would be negative. Yeah. Okay. So we have 0, negative 1. We have our east, which would be east would be left, so we'd be going negative, so we would go 0, negative 1. And then our west would be 1, 0. This would be negative 1, 0. I think it's positive actually the other way around. So what I'm thinking here is we probably want a helper function, right? To calculate our max distance, right? So let's do def helper. Let's initialize it for now. Should be our helper function to calculate the max distance, right? Then we're going to need some sort of while loop, right? So we can go, okay, well, for char in range S, okay, we want to loop to reach char, right? And now when we loop to reach char, we want to check, what are the 3 things that we want to check, right? We want to check, okay, well, we need a brute force, hashtag 1, oh, brute force, each north, south, east, and west, right? So that's the first thing. So we get our char. Let's print out char. Let's get rid of this helper function for now. Perhaps you forgot a comma. Oh. I think we need our commas in our hashy right here. Okay. Value cannot be interpreted as an integer. Length S. We print our schar. We're missing a parenthesis here. Whoops. Gotta wait a little bit. That leak code free life. Okay, sweet. So now we're printing out northwest, southeast, right? So now we've got our character, right? What do we want to do with this character? Well, we probably want to pass it into our helper function, right? So we'd probably go def helper function. We pass in our actual char. And then I don't know what else we probably pass in. I don't know, we'll leave that for now. Pass in our actual char, and then we'll come in here and we'll probably be like, okay, well, we want to go for U row, U column, in minus go dictionary. Okay, so here we probably want to pass in where we're at, right? So we'd probably need the max num that we're going to return right here, right? Probably going to need a max num, I think that's probably it. Probably just max num. We loop through. Probably want to call that function, right? So we'd probably call helper is equal to helper is equal to actually we'd probably just do helper pass in our schar, but we're gonna need to pass in more stuff. Probably our current distance, right? We probably need to pass in our current distance. But if we've got if we're looping through a new row, new column, we gotta have an original distance. But how do we keep track of that original distance? I don't know. Maybe we have to go for I in north, south, east, west. If if S char is equal to I, we would continue. We want to skip that because we want to skip the value that we're at, right? So when we skip that, probably want to call our helper. So this looks good. Probably want to return our max num, right? This is what we're going to return, or our max dist, I guess. Probably should call it not our max num. Our max distance. Our max distance here is equal to 0. We need to pass in a row and a column, but what are we currently at? Probably want to pass in our current row and column, right? So how would we get our current row and column? What's the best way to go about this? I don't know. Hey, bro, you gone? Such a nice job. Thank you, bro. How are you doing? Flying you, Raj. Appreciate you stopping by, bro, in the stream. Thanks for the comment. Trying to think here. How would we pass this in and loop through these values? I'm going to pass in our schar. How would we have a row and a column? Initially, you're at the origin 0, 0. You can change at most k characters to any of the 4 directions. So we started 0, 0. So maybe we can just pass in 0, 0. 0, 0. Maybe we should probably calculate the Manhattan distance from where we're at, maybe? Maybe we can already calculate the distance, right? To calculate Manhattan distance between two cells is the absolute value of xi and the absolute value of xj, right? So I guess we can start out with our original row and column, which is equal to 0. We can loop here. Check if it's not I. If it's not I, then damn, bro. I don't know. I'm trying to think. Damn, bro. I'm kind of stuck. I have the right idea, the way you want to solve it, but I just can't think about how I'd put it into code. So I guess it's a little bit of a skill issue, maybe. I don't know. Let's take a little discussion. But yes, I will happily work on McDonald's. Me thinking DP in this. I was thinking DP as well. Just do a dry one, focus on the understanding and order meaning. Interesting. Go for I. Let's go, Max, dude. What's up, Corey, bro? Let's go, dude. X and Y is equal to 0. We loop through the 4. We would do new row is equal to X plus new row. New col is equal to Y plus new col. Appreciate you stopping in, Corey, bro. You're a legend, dude. Thank you for hanging out, dude. X, Y is equal to 0. We loop through. Man, I'm stuck, dude. I'm literally stuck in this problem. Let's see. Let's copy the problem in the internet, dude. Fuck it. I'm gonna see what GPT thinks. Should help me, bro. I'm stuck, dude. Give me some pointers on what to do. You're in the right track. Try all combinations. You brute force approach, but let's clean up and complete your plan. Okay. Oh, Jesus. Definitely meant my dictop values. That's definitely what I meant. Our original char is equal to SI. We continue. So apparently here, what we want to add. Why did they do this here though? New path is equal to SI plus new char. New path is equal to SI plus I plus SI plus 1. Slicing it. So what are we doing here? I think this is meant to be char. Char. Then we calculate our max distance after. Max dist. Okay, we continue here. That was right. Char plus I. Let's char plus 1. Calculate our distance. Distance is equal to our helper function. But we want to pass in our new path. And here's where we calculate our max distance, right? So we go max distance is equal to the max of max distance with that current distance. So why here? Why do we add this new path here? We take the slice from where we're currently at in the beginning, plus our new I that we get from here, and then the rest. Ah, okay. Then we run our distance function with the new path. We go max dist is equal to max dist. So we're getting the whole path here. Right? Because we would have print this new path, which we can. I was thinking of the other way around. Like, I was thinking of going through each value and adding and checking each value as you iterate. But that's probably not the best way to do it either, now that I think about it. Because that wouldn't make sense, right? Like, when I was thinking of when I was thinking about the way we were solving it here, right? I was thinking of, okay, we have our k is equal to 1, right? And I was thinking of, we start off with this, and then we brute force, right? Let's change the color here. And then we brute force through this one, check this one, check this one, check this one, check this one. And we pick the best choice or whatever and go here. And then we keep going. We keep going. But I realized that wouldn't work, right? I don't know why I kind of thought about that. The brute force option is to loop through our specific char, check each different value if it would be better. If it is, then we make that our max distance, right? Because we can only change once. Or in this test case, we can only change once. So x is equal to dist. Then we would go up here. And we would return our helper char. So we initialize, which I'm kind of confused about here, we initialize two values here, x, y. X equals 0, y is equals 0. We loop through our directions. I guess we could go for D in we're passing in our, let's call this new S to make it a little bit more sense. This is new S. Pass in our new S for D in directions. For D in US. Direction US. We want to do we want to check we check inside our dictionary. That's our DX, our new X. Let's do NX, NY is equal to my dictionary. We get our value, what we get here, right? And then we would go, okay, well, you're my favorite programming streamer, bro. Let's go, dude. Thanks, Ryan, bro. Appreciate it. Love you guys, bro. Thank you for the support, bro. NX and Y in my dictionary distance. We want to x plus or equal to NX, Y plus or equal to MY. Right? And what would we check here? If we're checking these values, we're replacing for D and US, and we're checking this, the distance. This is where we probably want to calculate the absolute value, right, of our distance. So we'd probably go the absolute of, what is our formula? The absolute of X plus the absolute of Y. Right. Checking our distance here. We're looping through for D and US. We're checking NX and NY in my dictionary. D. We're adding up every single X, adding up every single Y, adding them together. Right? We return that here in the distance. And then we calculate the max distance of the two. We compare that to the max distance, right? So let's see what that returns, because I'm curious. New path is not defined. Whoops. Let's changing our variables too much, bro. Love from India, bro. Keep going, dude. Appreciate it, man. Thank you, dude. Thank you guys for the support. Thank you for that, boy. How's your day been, boy? You working on leak code too, bro? So we start off with south, right? Then we go east, then we go west, then we go the next value. We go north, south, east, west. And we keep changing our values. So we're brute forcing here. We're getting our output is 2, and our output is 6. Why are we getting that though? Let's fix this up a little bit. This has been a tough problem. I mean, it's been interesting the way to think about it. I would have never thought this would be a brute force problem. I would have thought this would be like probably like a BFS problem or something. I don't know. I don't know if BFS is the right way to do it. Starting with like using a queue and using, kind of thinking about it that way. I'm not sure though. I think what we got to do here is we got to calculate, well, what we want to do on max dist is equal to max distance, and then we want to pass in our original value, right, on US. No, our original S, right? But we want to pass in our helper function, helper S, because we need to do our original value too. We're still wrong here. Is this right? North is 0, 1. South is 0, -1. 1, -1. Got something wrong here. What are we missing here, dude? We got a bug. I don't know what it is. Okay, let's walk through the problem. So initialize our dictionary. Come down here. We don't need row and column anymore. Initialize our max distance. We loop through our original array, right? We get to our first value. Okay, so we calculate the new value, which looks correct, right? Southwest, southeast. Okay, we check the distance. We put that in the helper function. We check the distance. We bring it in. X is equal to 0 for D and US. NX and Y is equal to my dictionary D. X plus or equal to NX It's not the same thing though. Absolute value of x plus the absolute value of y. And then we check the max distance here. Seems right. And then we calculate it down here and we return our max distance. I don't know. I don't know what we're missing here, bro. I have to... What's my bug? I'm not sure, dude. I don't know. Very close to brute force is clean and solved for case equal. The only thing is that you're allowing exactly one change, but the process says at most k. Meaning that the original string 0 changes should also be considered, and you already do that with this line. There's a small thing. Expecting k to be greater than 1 to work. Oh, it's because we're doing it every single way. Man, bro. Checking every single value once. So this is probably only going to work for... in the case of 1. Bro. Damn, man. I'm going to look at some solutions. Take a look at a Python solution. Simulate a movement on a 2D grid. Each move we track them in hand distance from the origin. We're allowed to reverse the direction at most k times to try and maximize the final distance. Simulate the movement and compute the man. Store distances in a list. Iterate through the list. If the distance drops, we have the operations left. Apply. Love from Chicago, bro. Love from Charleston, bro. Keep going. Appreciate it, Zarif, dude. Thank you for that, dude. Thank you for jumping in, bro. What are we doing here? So we initialize x and y. We initialize our distances. We simulate the movement. Distance from origin. For move in S. If move is equal to north, we increase, blah, blah, blah. Simulate the movements. Distances dot append. The absolute x plus the absolute y. If k is equal to 0, we return the maximum distances. Max dis is equal to distances 1. Previous is equal to distances 0. Added. If the distance decreased, we can reverse a move. For I in range 1, blank distances, we check. If this is I is just previous, k is greater than 0. Added boost plus or equal to 0. So then we loop through one of length distances. K is greater than 0. I don't understand this part here. I'm a little confused with this part. Can we solve it with BFS and a Q? Index x, y. Remaining changes. Next distance we have visited set. Okay, I'm gonna redo this problem. We're kind of stuck on it, but I want to solve it. I think what we're gonna do here is we're gonna use a queue approach, right? So I'm gonna import a queue from collections, import DQ. What I'm going to do here is I'm going to initialize a queue. Q is equal to DQ. I'm going to q.append. I'm going to keep track of 0 being our index. When our row, our column. And our K, right? We loop through, we go while Q, okay? We want to pop everything, so we want our index, our row, our column, and our K, right? Is equal to Q dot pop left. I like to resort to BFS because I feel the most comfortable with BFS, and I think this problem can be solved using BFS. I think that we can simulate the movements on a graph, and because it's Q, we can have a case where we keep the same number, and we can have a case where we don't keep the same number. You know, where we can try looping through everything, adding a different direction, or we can keep it the same. And so the way I'm trying to think about this is, so we have our Q, right? Okay. We can simulate like a graph movement starting from 0, 0, right? We loop through each. So what we have here is we have north, west, south, and east, right? We loop through each one, right? In our state, for example, we start with index 0. We have our case 1 where we can keep north, right? Or we have a case, or this being our case 1, we could keep what we have, right? Or we can change what we have, right? So either we can go case 1, we keep north, we keep the same, or we can switch and we can check either south, west, or east, right? Whichever one is the greatest is the one that we're going to keep going with, right? So that means we're kind of brute forcing it, but like, are we brute forcing it? Yeah, I feel like we are. But we're also simulating like kind of a graph traversal. I think that's the way that you want to, that's the way I'm thinking about it. Is it probably the fastest way? Definitely not, but will it pass? I don't know, maybe. Let's have a look at the, yeah, I don't know if it'll pass, but it's going to 10 to the power of 5, but I don't know. Let's kind of see where it takes us. We're going to need a visited set, now that I think about it, right? And we're going to need a max distance. Max underscore distance is 0. We want to loop through. If we get to end, right? So if I is equal to the length of S, if it works, it works. Appreciate it. Sorry, I didn't see if I saw that message, bro, but appreciate that. If I is equal to the length of S minus 1, right? Then maybe like, I don't know, maybe max distance here or something. We could do max underscore distance, or what do we have? Max underscore distance. Like camel case, max dist is equal to the max dist. I guess of the absolute value of our row plus the absolute value of our column, I think. Really down here we want a case 1 where we keep the value. We want a case 2 where we don't keep the value. So I'm thinking, trying to think here. Let's make this k left. Index row call k left. I don't know, guys. I don't know. Curse state is equal to index row call k left. If curse state in visited, we want to continue. So then we want to do visited.add current state. We don't want to come back to this state, I guess, right? K left. Curse state index row call k left. If inside of visited, we just want to continue, right? We already visited this state. We know what the best thing is, right? I don't know, dude. Man, this problem is tough, dude. It's tough to think about, like. North, south, east, west. We got IQ is equal to DQ, Q dot append, visit is equal to set, max distance is equal to 0. What is your leak code user? My leak code user, I think it's just max PK, bro. That's my leak code user, max PK. Short and simple, bro. Short and simple. I think here current value is equal to SI. We want SI. Current value is equal to SI. Then we want what do we want to do with this current value? Probably want to do, well, new x, new y is equal to the, go inside of our dictionary, max underscore dictionary, current value. I mean, I guess we could just probably, I'm just going to get rid of this line. Get new direction, right? When we get our new direction, we pretty much want to if we want to keep the value, we want to do, we want to pass in everything again, right? So we'd start with our index. So our index will go up by 1. Our row would probably, we do our original row plus an x. Then our original col plus NC, or actually this should be, I'm going to make this NRNC. New row, standing for NRNC being new row, new column. So we would go, just to make sure that we are looking at the right thing, new row, new column. And then our K would stay the same. Our K left would stay the same, right? Because we're not changing our K at all. In case 2, we would try a different value, right? And the way that we would do this was we would probably go we'd probably need a loop, right? So we'd probably need to go, okay, well, for new row, new column in my dictionary.values, right? We have our new row and our new column is equal to my dictionary SI. So we're currently at the current index. This gives me the current index. Or actually, let's do, I think now we're actually going to need this. Let's do current value is equal to SI. Switch this to current value again. I think this is where we might need our current value, right? So if we go for new row and new col, or if we go for, let's go like for new val or something, right? So we're looping over the values, right? Then we check, okay, well, if new val is equal to our current val, then obviously we want to skip this value, right? Because then we're going to be doing the same thing in case 1, right? So that's why we skip the first value. If it's not, then we would go, okay, well, I guess we're looping through values here. We probably want to go keys, right? So then if we go, then we would go q.append. Oh no, we would have to go, we want our new row, new col is equal to minus core dictionary, new val, and then we would go q.append, and we would append our, go I plus 1 on the next value, we'd append our new row plus new row plus, holy shit, dude, I can't think right now. Plus our original row plus new row, col plus new col, and then we would decrease k left by 1, right? Decrease k left by 1. But what if, maybe we need some sort of bounds value. What if our k goes too low? Like, what if we keep looping through this and our k is too low? So I feel like we need some sort of check as well, right? So we would append that value. And outside of our queue, we would return our max, what do we call it? Max dist, right? We get here, if our I is equal to the last value, right? Then we would do our max distance with our absolute value of our row and our col. And I think here, I'm not 100% sure, but I think here we need to deal with k, right? Because if our k is less than 0, then we're technically invalid here, right? So maybe we would just, would we break? I don't know. This is kind of a rough kind of sketch idea. I don't know if this is really going to pass, but it kind of makes sense. But we're saving our state, which is important in BFS, tracking our visited, right? If we've looked at it before, then we know that we can add it. If we looked at it before, then we can just skip, right? Let's see what we get here when we run this. Let's see what errors we get. We're definitely going to get, okay, we got I is not defined. Where is I not defined? There is a what? There is a ace real killer between us. There, can you see him? I don't know what that means, Dora. Ace real killer. What does that mean, bro? Dora the Explorer. Eyes not defined. If I is equal to 0 and a length of S minus 1, we need index here, that's why. If index. Got I again. Need our index here. I guess we need to replace I with index everywhere. Where else do we have I? Index here. We need 4 arguments. Neuro. DQ.append takes exactly 1 argument 4 we're given. We need a double parentheses here. Mess that up here. Double parentheses. Let's run this. String is out of range. Curve value S index. How do we get out of range here? Shouldn't we catch that here? Maybe we have to deal with the 0 case. No. I don't know. Why are we getting string out of range here? String index is out of range. S index. If the length of S is equal to 0, what are we returning? An integer. I guess we would just return 0. Maybe we need to check this. I don't know. Nope. Something else. Why are we getting an out of range here? I don't know. Does anyone know why I'm getting an out of range here? I have no idea. One second. I don't know. I don't know why I'm getting this string out of index error. I'm honestly not sure. I have to ask, what's my bug here? Where's the out of range? I'm getting a string index out of range here, bro. I think it's right here where I check the S index. Curve value S index. Let me see. Off by 1 error in the base check. You're currently checking index equal to the length of S, but only catches when you're 1 step before the end. Since S index gets processed before the check, you should... Oh, okay. So I'm messing up my check here. This should be here. From India, keep going. Thank you, Harish, bro. Legend, dude. Thank you, bro. You keep going as well, bro. You're the GOAT, Harish. Legend, bro. Thank you. Oh, whoops. So it says here, you're currently checking, but this only catches you when you're 1 step before the end, since S index gets processed before the check. So why would that happen though? Current value S index. I wonder, was that it? Oh, I'm still getting the string index out of range. It's meant to be K left. Oh, I think we're forgetting our return here. I think that's the issue. I think we've got the return. There we go. It was the return. I wasn't returning anything. So I wonder, is it still meant to be -1? Change this to continue. We're getting here. We're not getting any output. We're getting a 0. Output is null. Output is null. Why are we getting a null output? Bro, what is going on here? Null output. What is going on? Get a new direction. K is equal to 1. Output is null. Bro, I have no idea what is going on here. Like, it says here. Shit, dude. Man, this problem is taking me an hour to look at, dude. Oh my gosh. Why are we not appending anything? We're getting an output of a null, so got our max distance here, so turn max distance. We should be at least be getting 0. Why are we getting a null? I have literally no idea. Index row, K left. Max distance as row, call. Why are we getting a null? I don't know. I have literally no idea why we're getting a null. Why are we getting null? Oh my gosh, dude. Am I that stupid? I'm not returning anything. Return. Do we need to return anything? Oh. It's because this is not a function. We're actually just returning straight away. Okay. Does that matter though? Would we... Probably not a return. Probably want to continue, right? Okay, now we're getting somewhere. So we got a... This one over here, we're getting 4. Ah, dude. Return. This exits functionality, yeah, no return value. I don't understand how I didn't see that earlier, but I don't know, it's alright. What am I missing here, dude? Bro, I have no idea, like... I have no idea what I'm missing, dude. I have no idea what my bug is. What is this? They're saying get rid of the visited. They're saying remove this visited. Keep going. Thank you, Rashid, bro. You're a legend, dude. Appreciate it. They're saying remove this visited. That this is not needed. What if I remove the visited set? Okay, we still got the same. Maybe the visited set wasn't really... Dude, my solution looks good, bro. Like, it literally looks good. I don't understand, like... Bro, this problem's literally pissing me off, dude. I cannot solve it, dude. We check our K left. Yo, Max, keep going. Appreciate that, Bruno. Good to see you again, bro. Thanks for stopping in. If you're not getting the job, how will I get the job? Ah, dude, just practice, bro. I'm getting cooked on this problem right now, silly cat. Oh, is it silly cat, dude? I'm getting cooked on the daily problem right now, dude. I've been sitting on this for like literally an hour, dude. I've been here for an hour, bro. And I'm still struggling, dude. I can't get this to work. Like, I tried a brute force solution at first, got screwed over, then tried to use BFS, which is what I'm using right now, simulating a graph traversal, and I'm getting cooked again. So, I don't know, bro. I don't know. And asking GPT to help me fix my bugs, and GPT can't even help me. So, I don't know. I think I'm cooked. I don't know, man. If anyone can see what I'm doing wrong here, I'll make the code a little bigger. I don't know. Someone can help me. I'd appreciate it, because I don't know. At this point, I don't know what I'm doing wrong, dude. Okay. New row, new column in my dictionary. We're doing the same thing, right? Row plus NR, col plus NC, K left, index plus 1. Let me see the whole thing. This is as much as I can show you, Zarif. Just know that I got a dictionary up here as the key. And I gotta fix this part here, but we're adding to the queue here. We're looping through for new val in my dictionary. Maybe the dot keys matters. If new value is equal to current value, we skip. Then we do new row, new column. It's equal to my dictionary, new val. And we add it here. Row plus new row, col plus new col, k minus 1. That's the way to think about it. Current value is not defined. This index here. Oh my gosh, dude. I don't know what I'm doing wrong, bro. I literally have no idea. Like, I'm so stuck, dude. I have no idea. I have absolutely no idea. I might have to give up on the problem, dude, but I just like don't want to. I spent so long doing it. I don't know. I want to solve it so bad, bro. But I'm just getting cooked. Got rid of our visitor array. If index is equal to length s. We're just simulating a graph traversal. Like, it seems so simple. Like, I don't know what I'm doing wrong. Like, bro. Dude, this is literally killing me, bro. Are you ever using max dist? Yeah, I am, dude. Up here. I'm checking the length against it, so when we get to the end, we check the max distance. Like, if index gets all the way to the end, so if we generate s, we get a length of s, then we return the max distance here. Maybe this should be -1. I had it originally as -1, but nope. Like, I don't know, dude. Like, Right, now they're telling me, Zarif, I gotta add back the dictionary. They want me to add back a visitor array. These motherfuckers on here, bro. What are they doing here now? Keys equal to XY if key and visited. Visited keys equal to K left. Check if we reach the end. We got a new row, new column. Yo, what's up? Oh man, they are confused, bro. Yeah, dude, fucking GPT's confused. Can't even help me solve my bug. Shahid, bro, what's up, dude? Hope you are doing very well. Thank you, bro. Hope you're doing well too, dude. Appreciate you stopping by, bro. How's your day been, bro? Okay, I'm gonna follow this, and I'm gonna add a visitor dictionary here. Right. Let's move this. Right, we check here. Let's move this down here. We make our current state again, like what we did before. But this time, instead of including K left, they want us to include row call. They don't want us to include, if cur state, they don't want us to include our K value. So if cur state is in visited, and visited new row, sorry, not new row, cur state, if cur state in visited cur state is greater than or equal to K left, right? So if our cur state is in visited and visited cur state, so we're checking our value, visited cur state is greater than or equal to cur left. We continue. Visited key is equal to K left. So I assume what they want us to do here. So visited dict instead of a set. What they want us to do here is they want us to check the current state, but they also want us to check if our K left is greater than or equal to what we have before. Because if it's less than, then it won't work. I don't know. I don't know. Oh, whoops. This is cur state, not key. No, bro. I don't know what it is, bro. I think I'm going to give up on the problem. I don't know. I don't know. I cannot solve it, dude. I think I'm taking the L on this one, bro. I don't want to take the L, but I think some days you just got to take the L. Did anyone solve it using BFS, dude? Maybe you can't solve it using BFS. I don't know, dude. 2 simple lines of code. Look at this guy, bro, flexing on me, bro. 2 lines of code, bro. And look what I've done. All this garbage. 50 lines of code versus 2 lines of code right here. Bro, like, checking 4 directions. What do they do here? Res is equal to 0. For directions in northeast, south, west, northwest. KK dist is equal to K and 0 for C and S. Distance plus or equal to C in directions. Or KK is greater than 0 or minus 1. Like, bro, like, look at this guy, bro. Gotta reconvene for this one. Yeah, bro. I got cooked. I got cooked today. Some days you just get cooked. What are they doing here? Making everything equal to 0. I'm good. Thank you, Max. That's great. That's great to hear, Shahid. That's great to hear, bro. You should try this problem of the day here, dude. Literally getting destroyed. I just think BFS probably isn't the way to go about it. I kind of thought maybe it was, but maybe not. Is this an array length error or something? No, dude. I don't know. I'm passing some test cases, but then I'm not passing some. I have no idea what it is. I think it's something to do with... I don't know. I think it's something to do with the visit set. Maybe it isn't. Maybe it's just... I don't know. I have no idea. But I'm trying to figure out what this guy's doing, so... If this is this, plus equal 1, plus equal 1, plus equal 1, steps I plus 1. I don't know. What I have here just seems right. Like, it seems like it works, but... I don't know. What do they do here? We track the robot's movements. Calculates when distance from the origin after every step. If the character was wrongly moved, we are allowed to change up to K moves. He's contributing at most 2 units extra to the distance, fixing a wrong direction. So at every step, compute the current Manhattan distance. Calculate how many moves are missing from optimal. Fix up to 2 times K of those maximized distances. Approach, traverse string, count, calculate. Yeah, bro. I think I'm just gonna come back to the problem. I got cooked. I got fucked. Take the L. Gotta move on. Hopefully I can make myself feel better doing something else. Spent, what, an hour and a half on that problem, could not solve it. I'm gonna be working at McDonald's, dude. Low key. Nah, I'm joking. Okay. Let's see what we get. Let's take a look at this one. You're still a legend. Thank you, Corey. Thank you, bro. I'm gonna be putting the fries in the bag, bro. I'm gonna be putting the fries in the bag. Like, let's take a look at this problem. From the root of a binary tree, the value of a target node target, and an integer k, return an array of the values of all the nodes that have a distance k from the target node. The nodes that have a distance, so what are we given here? We're given a root, we're given a target, k is equal to 2. Given the root of a binary tree, the value of a target node, okay, and an integer k, return an array of the values of all the nodes that have a distance k from the target node. So if we get this node, we want to return 7, 4, 1. Okay. We're given a tree node here. Nodes that are a distance of 2 from the target node with a value of 5, a value 7, 4, and 1. Hash table. Trying to think the intuition for this problem. We get to this value. We have to find a way back. This is an interesting problem. I don't really have any intuition on this problem. We cannot go back in a tree, but we can go anywhere in a graph. If we reconstruct a tree from the graph, that would be much easier to handle. By this hint, I solved. Thank you. This tip is perfect. This tip's solid tip. Thank you. So we can modify the DFS to work on the parent nodes while backtracking. My solution using backtracking without parent pointers. Problem should be LeetCode hard. It's a graph question. So if we transform this into a graph, is that the way to go? We come from here and we go. Can we somehow calculate like an adjacency list from this graph and treat it as it's a graph from the target node? Run a BFS from the target node? Well, technically, So now I'm kind of thinking maybe the intuition is that somehow we can figure out how we can convert this node, this graph of, you know, a tree, into an adjacency list. We can then run BFS from the target node, run it the BFS twice, and whatever it runs from twice is the nodes that we add to our res and return. But the question is, how do we convert this into an adjacency list? Because I've never really done that before. What would be a simple way to convert this to an adjacency list? Well, if we run from our node and then we add our children, I feel like that would work, right? So our first step here is I think we convert this to an adjacency list for graph traversal, right? The way we're going to do that is that we're going to use a recursive function, pass in our root. Okay. We're going to make a graph. Oh, would this work though? Maybe we make the graph outside of this function. We loop through this and we go, okay, well, our base case here would be, okay, well, if not node, we just return, right? We add our children, right? We would go, okay, well, how can we get the number of nodes here? What are we giving? We're giving a root, a target, and a k. Well, we're not giving the length. Can we get the length of a tree easily? Can we get the length of a tree? I'd have never even looked this up, to be honest. Length of a tree in Python. Can you do that somehow? I don't know. No, you can't. Okay. I thought so. I was just trying to... How can we convert a tree to an adjacency list? Distance k binary tree. The thing is here is that you could convert this with a graph, but the thing is that we've got to initialize it with, you know, an empty array here, right? And if we don't have an initializer, it's not going to work. Well, actually, maybe we can do graph. Let's do, okay, well, if maybe if the root I think we would keep this base case. Maybe we would just go graph root dot val graph root dot val dot append parent dot val. Graph root dot val dot append parent dot val. But then how would we pass our child? That doesn't work. No, that's not gonna work. Anyone here know how to convert this to an adjacency list? Because I'm struggling, dude. These are tough problems, man, today, dude. It's been rough. If graph root.val, sorry, wait. If root.val not in graph, then we do graph root.val is equal to this, right? And then we would go, okay, we would call DFS node.left. DFS node.left. Should we want this to be node? Node. DFS node.right. Then can we do graph node dot append node dot left graph node dot val, sorry, we need to add the dot val here, dot append node dot right, and then we call our DFS functions. Go to our next value. It'll return. This needs to be first, so we don't get any issues. Adds the values, adds the children, keeps going. I think we need to have a reference to our non-local here. Non-local graph. I don't know. Let's see if this works, dude. DFS. We start at root. Let's print our graph. This is going to be interesting. Okay, we're going to get key value error. If root.val not in graph, graph root.val is equal to this, we append the children. Okay, this is meant to be node, that's why we're getting an error. We're getting a key error here. Okay, nope, didn't work. Okay, I'm not sure. How do we, I need help making this JSON list. How do we make this JSON C list? I don't know how to make this. We're close though. You're using graph root.val is equal to this instead of graph node.val. Oh, shit. Another one here. Oh my gosh. Oh, bro, what is this, dude? Oh my gosh. Node.left.val. There we go. This might fix it. This might fix it, low key. Nope. Can you not do that? Node.left.val? Object has no attribute val. Bro, what is going on? Non-object has no attribute val. Why doesn't this work, dude? What is the error here? Can you not access node.left.val in Python? Why does this not work? I thought you could, to be honest. Your current node doesn't handle none children correctly. It blindly adds none.val, which will raise an attribute error, which is what we're getting. If node.left or node.right is none, you're trying to access .val on none. Ah, okay. Right, because we don't know 100% if there is going to be a left or a right. That's why we're getting an attribute error, so... How can we do that though? If not node node.val, we can check. Okay, if node.left, we append. So we check. Node.right, we append. Right? If node.left are not in graph, that is true. We do need... let me see what we get here. Or if we have the if statement here. Okay, we got somewhere. 351. We get 562. 6. Nothing. 274. 7 nothing. 4 nothing. 108. 0 is nothing and 8 is nothing. This is correct, but we're also wrong at the same time because we also need to do the direction back. This is a directed graph technically. This needs to be undirected because we can go anywhere in this graph. So I think what we got to do is we got to now figure out how we can append itself as well, or its parent. So if no dot left of our not in graph. Okay, so we check here if no dot left dot val not in graph, right? So we're checking not in graph. Then we can initialize that here. We go graph no dot left dot val is equal to an array. Graph no dot left dot val is equal to no dot val. We would do the same over here for our right side as well. If no dot right dot val not in graph, our graph no dot right dot val is equal to this. But here we're doing the parent. Now graph no dot right dot val is equal to no dot val. And I believe DFS no dot left. We can call our DFS no dot right and get rid of that here. Let's see what that gives us here. No attribute append. Into object has no attribute append. Why are we getting this error here? Oh, dude, what is going on right now? Graph no dot val dot append no dot left dot val. But why are we getting no attribute append? Why is that, dude? I have no idea. If no dot val not in graph, he was just working without all this shit that we had here. Bro, what is our issue right now, dude? Append. I don't know what it is. I don't know what our bug is. Why are we getting this bug? Why are we getting this bug? You're overriding the entire list with a single int no dot val. These lines. How am I overriding it? I'm putting the parent. Oh my gosh, dude, I'm not appending here. That's why. Bro, what am I doing? I'm assigning the variable, not appending. Oh my gosh, dude. What am I doing? How did I not see that? No dot val. There we go. Now this should work. Okay. So now we get 351. 5 is 362. 6 is just 5. 2 is 574. 7 is 2. 4 is 2. And we got our 1, which is 3, 0, and 8. 0, which is 1. And our 8, which would be 1, and our 8, which would be 1. Okay. Finally. Okay, so we've got our graph, right? Okay, so now our step 2 here is we need to run BFS from here, right? So to run BFS, let's import from collections. We import our DQ, right? We run BFS from here, right? So how do we run BFS? Well, we started our DQ, right? And now what do we want to append here? Well, we want to probably append, we want to start at 5, right? And how would we start at that? Well, we're probably going to have to loop until we find it. So I guess we'd probably go for key in, graph. If key is equal to target, right? Because we got our target here. Ooh, it's a tree node though. So I guess it would be target.val. Good thing I looked at that. Gotta fix my hair, bro. Oh my god. I'm getting too sweaty, man. I'm getting too sweaty on the problems. For key in graph, if key is equal to the target val, then what we want to do is we want to append that to our queue. So we would go, okay, well, queue.append, and we would append our row. No, not our row, sorry. This is the node that we want to look at, right? We get our node. What else do we need, right? We probably need a visitor array, right? Visited is equal to set. We don't want to be going back. We don't need a direction since we just need a basic direction. So then, now we go while queue. We want to do queue.popleft, right? And we pop our node. Okay. Queue.popleft, sorry. My bad. And this is our current node that we're looking at, right? For a BFS, what we want to do is that we want to loop through our neighbors. So we go, okay, well, for neighbor in graph node, okay, we want to do for neighbor in graph node. So now we're looking in here. So now we're at 5. We want to look at 3, 6, and 2. So now that I think about it, we probably want to add 1, right? And 1 is going to be our counter here that we're at, right? So, well, no, that doesn't count. So we're technically at 0. So we should probably put 0 here. We have our node and our val, I guess we can call it, right? And we go for neighbor in graph node. We check our, for neighbor in graph node, we want to go queue.append. We want to append our neighbor, and then we want to append our val, right? But we want to add 1 when we append to it. So really what we're checking here is we're checking, okay, well, if val is equal to k, then we want to append, right? So then we would go, okay, well, now that reminds me, we needed to create a res array. Make our res array here. and we go, okay, well, what do we want to append? If our val is k and we want to go res dot append, we want to append our node, right? So if val is equal to k, we append our node. Okay, res dot append. For neighbor and graph node, we do q dot append neighbor, val plus 1. We want to do visited dot add node. Right? All these values, can they be unique or can we have duplicates? All the values are unique. Okay, so we get that. We append our res. We get our visited. I guess if node in visited, I guess what do we want to do? We probably just want to continue, right? We don't really care about that node if it's already, if we go back. We add our visited here in the beginning. We add our visited. Check if it's in visited. Wait, how's that going to work if node is in visited? Whoops, we'd probably have to do this first. Then we check if we're in K. We append our neighbors. I think that should be good. We return our res. I think this should solve it. Nope. What do we get? Cannot access local variable node where it is not associated with a value. Oh, whoops, q dot append key. That's what I mean. Key. dq dot append takes one argument, 2 given. Oh, whoops, we forgot our parenthesis here. Keep pushing, man. We're about to fucking solve it. Yeah, we are, bro. We are, Shahid, dude. Thank you, bro. Hopefully this solves it. There we go, bro. I solved it, dude. Finally, dude. We got cooked on the first problem. Oh, actually, wait. Hang on. Let's make sure we submitted it. There we go, bro. There we go. We solved it. We got cooked on the first problem. Spent like an hour and a half on it. We solved it, dude. Even though that was probably a pretty basic problem, but we solved it. That's a dub, bro. That's a dub, dude. Goated, bro. Let's go, Tom. Yes, dude. Let's go, dude. Goated. That was a shit ton of fucking code. Fuck yeah, that was a tough one. Yeah, it has some tough, like, theoretical problem to it, but I mean, the BFS was easy to solve. Like, that was, like, such a straightforward BFS. Like, yeah. Anyway. Let's look at another problem. Maybe something easy. Something we've been getting cooked in some other problems. So let's take a look at something. I do want to finish our LeetCode 75. We're only like 2 questions away from finishing it. But there's 2 questions in here that I just like I remember trying and I failed at. So maybe we definitely got to come back to one of these ones, but I don't know. Let's take a look at top 100 liked. Take a look at Tucson, dude. Classic problem. Let's take a look at a easy linked list problem. Something that we've done before. Been a while, probably. Yeah, been about 6 months since we solved this. So let's take a look. Given the heads of 2 singly linked lists, head A and head B, return the node at which the 2 lists intersect. If the 2 linked lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1. Okay, we got that. Test cases generated says that there are no cycles anywhere in the entire linked list structure. Note that the linked list must retain their original structure after the function returns. The program is not given these inputs. Intersect val. Damn, man, we're giving a bunch of bullshit. What is skip A, dude? I don't know what that is. Skip A, the number of nodes to skip ahead in list A starting from the head to get to the intersected node. Okay. We're given the two lists, the intersect val. The intersect node's value is 8. Note that this must not be 0 if the two lists intersect. I'm trying to think here. Well, obviously this linked list doesn't have a cycle in it, so there's no way that you can do a fast and slow pointer and detect the cycle. That should be possible in end time complexity. Thank you, Leaky, bro. Appreciate that. To be honest, I don't really have the intuition or how I should probably begin this problem. Can you write a solution of end time and over one memory? Trying to think. I don't know. How would we solve it? This one doesn't even have one. No intersection at all. How would we detect an intersection? Great, they don't give us any, like, romantic two-pointers. If I wandered to the end of the world and still cannot find you, I will take another path in searching you. Well, you can check how many steps it took for both to reach to the end. And if the end matches, it means there was a connection. My first approach. Well, you can check how many steps it took for both to reach to the end. And if the end matches, it means there was a connection. What do you mean by that, Leaky? I don't really get. Because if we go to the end and we count the number of steps, wouldn't that really tell us nothing? I don't know. I mean, that's in my head. I don't know if that would. Because I'm thinking the test case generates that there are no cycles anywhere in the entire linked list. So if there's no cycles, if there was a cycle, then I feel like it would be easy to, find the intersection. I mean, you can use a fast and a slow pointer and keep going in circles until they meet. Like, never mind, I read the problem wrong. It's all good, bro. It's all good. If you have any ideas, bro, let me know. Trying to think here. What did they give us in the problem here, dude? I'm so confused with all this shit they give us. They give us head A and head B. That's it. Giving us all this other crap over here confuses me. So I think probably the base case here would probably be, well, if not head A and not head B, we can return none, right? Is that what we return, or do we return -1? Yeah, return null. Okay. So if our heads just don't exist and there's nothing there, we return none. I feel like that's pretty obvious, right? There's nothing there, we return nothing, right? Maybe there's a way that we can go through it, and if we get to the end, can we somehow, like, or Man, I read the prompt wrong. Or what do you think, Leaky dude? I don't know. If head A or head B. I don't know what you're saying, bro. If head A or head B. Oh yeah, that's what I meant. Yeah, if head A or yeah, you're right. Yeah, sorry, I messed that up. The if statement should be or, not and. Yeah, appreciate that, dude. Yeah, I just made a mistake there when I was thinking about it. Dude, honestly, I don't know the intuition, and this is an easy problem. I don't know. I don't have the intuition behind it. I don't know. For example, is 1, but why not return 8? I don't know, dude. I actually don't know the intuition behind this problem. Let's take a look. I have to revisit it. I can't remember. This is the one of the problem where it is difficult to come up with the intuition. Yeah, I agree, Midnight Clarity. I don't know the intuition. I thought with linked list, really the only... Are you using Linux for daily use? I am an ass, yeah. I use Linux every day. I dual boot Windows and Linux, so like if I want to play games, I boot into Windows, but like I am thinking to remove Windows. Yeah, you should definitely try Linux, bro. It's pretty goated. You have to look at the solution for once, and then you remember this forever. If it's a list, you can see the last matching elements and see when it's last matching elements. This is my approach initially. Yeah, Midlife, I've actually solved this problem before, bro. I've solved it 6 months ago, but I just don't remember the intuition or how I did it. My basic... Do you really dual boot? I do. Zarif, I do dual boot. This is my approach initially, like 1, 2, 3, 0, 1, 2, 3, check 3, last matching. If it's a list, you could see that the last matching elements and see when it's the last matching elements. And the fourth doesn't match, so it means the connection started at 1. I am in love with Pop OS. Pop OS is go to dude. Hint, you have to iterate it 2 times. It's a math trick. Man, there's so many people talking in the chat, dude. Yeah, Mas, you should definitely do boot Windows and Linux, dude. I wouldn't do it by itself. I mean, unless I play games, so it works better for me, but someone said a hint, you have to iterate 2 times. It's a math trick. Yeah. Intuition. The chance to convert 2 single links to the potential different lengths. Is that where they intersect? To find the intersection without extra memory for data structures like hash sets or arrays. We use a 2-pointer technique. Intuitively, if you traverse both lists in tandem, they will reach to the intersection point at the same time if they are on the same length. However, when they are on different lengths, simply traversing them simultaneously won't work because 1 pointer. I appreciate Shahid, dude. Thank you, dude. Thank you for that. I just hit subscribe. You're putting out valuable content and helping the community. Please keep up the good work. I appreciate that, bro. Just kind of grinding, man. I don't know. Thought it'd be fun to record myself do it. Like the boot menu doesn't appear. It boot directly into Windows. No, the boot menu appears when I start up my computer. I can choose if I want to boot into Linux or Windows. I've got mine booted on separate hard drives though. Maybe check the length first, run then second, run give the longest list a head start. Maybe check first, run, then run them both at equal length and see if they connect. Yeah, Leaky, I don't know, dude. I really don't know. I mean, you might be right. Do you have a NVIDIA driver? How did you configure it in Linux Mint? I do have a NVIDIA driver. I just installed the drivers, bro. It was, pretty straightforward. It's not too bad, Anas. Just like give it. I just googled it, man. To be honest, I somehow installed them, but I think I just downloaded the drivers or something. But I don't know. Trick length of list 1 plus length of list 2 will always be constant. Trick length of list 1 plus. So check both length. What do you mean, Leaky? Check both the length, then run them both. Sorry, man. You guys are telling me two different things. I'm just a little. Initialize 2 pointers A and B to head A and head B respectively. And on the first list, remove first two elements so both lists are same length. Leaky, I feel like this is a linked list, bro. This isn't an array, dude. Like, I feel like because before I used Linux Mint, but my second model wasn't working due to an NVIDIA driver. Yeah, no, dude, I got no idea, bro. I used 2 monitors and I've used it with 3 before and it was completely fine. Actually, yesterday when I was streaming, my computer literally died midstream, and I had to restart my computer, and then when I booted it up, I had issues with the kernel and everything. I had to boot from timeshift, like boot from a backup. You have to run it twice. First run to check the length, second run to find connection. This is my first attempt. Send the problem link. I want to try my solution. Just search it up, Leaky, dude. It's just search it on the internet. Just search intersection of 2 linked lists. It'll come up, dude. On LeetCode. So we initialize 2 pointers A and B to head A and head B respectively. All the best, man. I subscribe to you. We'll check out your channel later. I'm grinding too until I get a change of job, lol. Well, good luck to you midlife, bro. Appreciate you stopping by, man. And I appreciate you subbing, dude. Thank you, dude. Keep grinding too, bro. The grind doesn't stop, man. That's why I got to look back at some of these old problems that I've solved, dude, because I cannot solve them. Well, A is not equal to B. If A has not reached the end of the list, move to next point at A is equal to A.next. Otherwise, start from the beginning of head B. A is equal to head B. If B has not reached the end of a list, move to the next node, B.next. Otherwise, start from the beginning, head A, B. The loop exits when both A and B are null, no intersection, or A and B meet at the intersection node. The actual implementation, here's what the critical part of the code looks like. Is this it? Is this... Dude, it's been forever since I... I probably got to analyze this for a second, but... A is equal to head A, B is equal to head B. Is this really it, bro? This is the code, dude. Like, okay, alright. So what do we do here? We do A is equal to head A, B is equal to head B. While A does not equal B, A is equal to A.next. If A, else head B. So how does this work, dude? I gotta revisit this, bro. Let's draw this, right? So we're given A1. And we're given A2. Given C1. Man, usually I'm actually pretty decent at linked list problems, but I feel like just the intuition wasn't there for this problem. B3. We all come together at C1, right? Then we get C2, C3. So let's switch colors. Let's go blue or something. We started A1, right? And we go, okay, A dot next if A else B, right? So we go A dot next, right? B1 goes A dot next, right? A dot next, 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 right? And B goes here. Then we get to the final iteration here. A is equal to A dot next if A. Okay, so we go one more if A. So we go one more. We go one more here. We see that there's nothing. If A dot next, if A is equal to A dot next if A, else head B. So then what? We move this pointer now. So this goes here. Alright, let's switch colors. This pointer now goes here. While A does not equal B. And we just keep going. So then we would go here. This one will go here, back over here. Right? And we would just keep going. Would that eventually, would A equal to B eventually? I think it would. So then we go here. Wait, hang on. Where were we at, dude? And then we go here. Wait, hang on. Where were we at here? Okay, wait, let's go back. I kind of lost myself. Oh, so eventually there must be a collision. Yeah, exactly. Yeah, there is. But I kind of want to see that collision here just to be sure. So we come here. This moves over here, right? And we're pointing here. This is at null still, right? And then we come to the next iteration. This goes here. Then this moves over here. And we're at this point. Then the next iteration we go here. Then we go here. Then we go here. And then we go here. And we get the intersection here. Interesting way to solve this. Yeah, the thing is with linked list problems, man, is that there's like only two ways to solve them, right? There's only really two patterns for linked lists, right? And it's either a fast and a slow. Really, fast and slow pointers is everything in linked list, man. It's literally everything is a fast and a slow pointer. And then cycles, right? If there's a cycle in the linked list to find like intersections or to find things, cycles are another way to solve them using fast and slow pointers. But the intuition wasn't there when I was like, okay, we loop through this and then we go back to the other side. Like, I just didn't think about that. Like, I don't know, but that's let's take a look. Linked list patterns, fully code. Fast and slow. Reversing a linked list. Yeah, we know that. Merging a linked list. Okay, yeah, we know that. When to use dummy nodes. Dummy nodes will help you simplify your code by removing the need to handle the edge cases when your list is empty. Okay. Interesting. So yeah, they're pretty basic data structure. Like, there's not, you only have to remember a few things for them, really. We had 3 common questions that show up most frequently in linked list operation. It teaches you when and why you should use a dummy node to simplify your logic in your code. All right, well, I'm gonna call it there. I've been gone for about 2 hours, so I appreciate everyone watching, and thank you guys for all the nice messages and the support and also the help. So I'll be back at it. I won't be here tomorrow. My friend's coming in town, so I won't be able to make a video, but I'll be here. I'll be recording again on Sunday. So appreciate you guys. Appreciate the support this week, and I will see you guys on Sunday. So appreciate you guys.